For class example number 6 on page 64, we're going to use the exponent laws to simplify all of these. Let's take a look at a. We've got a to the power 4 times by a to the power 3. Since we're multiplying here, we're going to be using the product law. In that case, a to the power 4, a to the power times by a to the power of 3, you're going to be adding the two exponents together. So in this case, it's the equivalent of saying a to the power of 4 plus 3, which is going to be a to the power of 7. Same with b, we've got x to the power of 6 times by x. Now don't get confused because there's no exponent there. X to the power of, well, it looks like nothing isn't really nothing at all. This is actually x to the power of 6 times by x to the power of 1. You can think of it that way. In that case, you're still using the exponent law. This is going to be x to the power of 6 plus 1, which will give you x to the power of 7. C, you have b to the power 7 times by b to the power of 0 times by b to the power of 4. Again, because you're multiplying these together, this is equivalent to saying b to the power 7 plus 0 plus 4. You're adding them together, so you should be getting b to the power of 11. D, on the other hand, we're going to be using the quotient law. In that case, instead of adding the exponents together, you're actually going to be subtracting them. So in this case, this is the equivalent of saying x to the power of 8 minus 4, which will give you x to the power of 4. Same thing with this one. You have y to the power of 10 divided by y to the power of 2. We're using the quotient law again, which means that you're going to be subtracting the exponents. This is the equivalent of saying y to the power of 10 minus 2, so your answer should be y to the power of 8. Next up, you're using the power of a power law, because you've got an exponent on the inside of the brackets and an exponent on the outside of the brackets. In this case, what's happening here is you are actually multiplying this together. You get a to the power 4 times by a to the power 4 times by a to the power 4. Now, if we think about the product law, all this means is we're going to have a to the power 4 plus 4 plus 4, which is basically going to be a to the power of 12. Now, if you take a look at the original question here, you've got a to the power 4 with 3 on the outside. This is just being multiplied together. 4 times 3 is equal to 12. The power of a power law is still being used for g. This is the same as saying y to the power 5 times by 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 y to the power 5. So if you look at it in terms of the product law, this is the same as saying y to the power 5 plus 5 plus 5 plus 5 plus 5, which is basically y to the power 25. On the other hand, using the power of a power law, y to the power 5 in brackets raised to the power of 5, just multiply those two together, you should get y to the power of 25. On the other hand, we have the power of a quotient law, which is what we're going to be following for this one. This y applies to the x, and it applies to the y as well. Okay, so when you work this out, this is going to be x to the power of 9 over y to the power of 9. We're using the power of a quotient law for I as well. So this, when you work it out, is going to be c squared over 4 squared. Now we want to expand this out a bit. This is going to be c squared over, well, 4 to the power of 2 is going to be 16. For j, you're going to be using the power of a product law. In that case, everything is affected by that power to the 6. So st to the power of 6, this is going to be s to the power of 6 times by t to the power of 6. K, you'll also be using the power of a product law. You've got a whole bunch of stuff inside brackets that are going to be raised to the power of 5. That 5 is going to affect the 2 as well as the a. So this is essentially saying 2 to the power of 5 times by a to the power of 5. When you expand out the 2, you should get 32 and then a to the power of 5. For I, same thing, it's power of product law. So this 4 is going to affect the negative 3. It's going to affect the p and the q. So you're going to have negative 3 to the power 4, and you've got p to the power 4, and you've got q to the power 4. You'll notice I actually put this in brackets. This is just to remind myself that we do have a negative 3 in this case. And this negative is in the bracket, so that's 4 is going to affect the negative as well. This is going to result in a positive number. So negative 3 to the power 4 is going to be positive 81. And the rest is done for you. P to the power of 4, q to the power of 4.